Okay, so you're here to learn about Frisby.js. Frisby.js is a REST API testing tool that I created back in 2011. It's gone through an overhaul recently. I am Vance Lucas, and there'll be a little bit more about me at the end. I didn't want to put it at the beginning this time. But if you want to check out Frisby, it's on NPM. You can search for Frisby. It's B-Y, not B-E-E, like the trademarked Frisby term. So just note that if you're searching for it. It's a relatively popular package on NPM. It gets over 10,000 downloads a week on average. So it's not like a super popular package, but it is pretty widely used. It's in its second major version. Did a major overhaul in 2017 and released a version 2 from the first version that was released, which I'll call V1, but it really was never actually a V1. It was like a V0 point something, and then it just got widely used as that. So the downloads per month chart looks something like this. This goes back to, the key is really hard to read at the bottom. It's like May 2015-ish. It was relatively unknown for many years. I actually publicly released the first package in 2011. Yeah, 2011. And then it went for, I guess, the first 4 years, relatively unused at all, ignored. And then all of a sudden it kind of got picked up. So, and then you see the chart here. So averaging, I don't know, anywhere between 40 and 50,000 downloads a month. So again, it's not like the most popular package on NPM by a long shot, but it has some pretty good use. So why did I make Frisby? It was part of a, kind of take you through the story of like how I came up, how I ran into the problem and how I came up with it. And really, it's because of the Bible app. So in 2011, I was a contractor on the team building the Bible app, doing API support behind the Bible app. That's LifeChurch U version. This is when it was LifeChurch TV, before they rebranded to Life.Church. And they were switching API versions. So they were going from API version 1 to 2. And the unique thing about this switch was that they actually intentionally didn't want to change any of the API resulting response formats or types or keys or anything like that. So they wanted to specifically maintain parity between version 1 and 2. The switch was based on something else. So they wanted to prevent a ton of breaking changes. They had lots and lots of mobile clients. It's really a high-risk thing to create a whole new version of your API and then switch from a, I guess, management or code owner standpoint. So they had come with lots of risk. They wanted to minimize this. They wanted to, just like the previous slide, they just wanted to ensure there was no breaking changes across versions. So they had lots and lots and lots of clients depending on this API. Some of them they couldn't make any changes to because they were written by outside contractors or outside companies for them. So they didn't have necessarily anyone on the local team that had knowledge of how that app was built, so they couldn't go in and make a bunch of underlying changes. There's probably a story in here about the code you're writing now is going to live longer than you expect it to. So the version 1 of their API, they just had to live with whatever the result, response format was because of all the things that were coded to it. But that's not the story of this presentation. So, but that's kind of what it was. So it was just too expensive for them to make all these changes. So they say they were switching programming language too. They were switching from a Kahana PHP app that was like self-hosted on servers to Python and Google App Engine. So they were migrating to the cloud. Whole different programming languages, which comes with its own challenge of sometimes programming languages can serialize things from the database differently on the end than another programming language might, depending on how it's written. So the JSON serialization functions can be different, result in different outputs too, for things like dates and booleans and things like that. They're probably going to be mostly the same, but you might catch a few differences. one of the ones we ran into was Boolean values coming from Postgres were string like capital T and capital F and not actual Booleans. So that was one of the things we ran into that broke the API during this that Frisby helped catch, or a integration test against the API helped catch. So the requirements were we needed an integration test for the API. That was really the solution. So we had to make sure, and we had to do it in parallel, version 1 and version 2, to make sure that there was no breaking changes between them. So they had to be really mostly the same, other than there was some hostname updates that had changed, but the resulting output had to stay the same. So it had to integrate with the continuous integration build. So it had to integrate with their build pipeline so that it would actually break the build if you broke the API like it should. It should fail the build if the API is broken and not let you, push that commit. It had to be able to test structure, even deep nested keys, and then their types. So is it a string? Is it a date? Is it a Boolean? An array of stuff. What is it? It also had to be able to test response, anything about the response. So the response body, the status, headers, things like that. It had to have specific tests for error responses as well. If there's like a form that you're submitting and you have errors, they were displaying some of those errors friendly on the client. Had to run custom assertions, and it had to have support for sending custom headers for auth and cookies and other things like that. So this was 2011 when this was first built. The testing landscape for something like this, it didn't look too good. There was some things out there. You could, most of them that were actually integration tests that were hitting an HTTP endpoint were going to be something like Selenium or things like that that would actually drive a headless browser. There wasn't anything lighter than that that was purpose-built for API testing or REST API testing. People had kind of, made their own HTTP calls inside another test framework like, Jasmine or Mocha or something like that. So there wasn't anything that abstracted a lot of the, the hard parts of that, various formatting and things that come along with making those requests. So I decided to write one as part of solving these requirements for ensuring the API wouldn't break across versions. And thankfully, LifeChurch let me release that open source as well. So that's why Frisby exists and is open source. So thank you, LifeChurch, if you're listening, if you're out there. And so now I want to go into a little bit how I built Frisby and why and the thoughts behind it, and really the differences between what I'm calling version 1, which is really released as 0. Whatever. I think the latest one was 0.86, but it's effectively version 1 and then version 2, which is actually version 2. So I'll have some more code examples. I kind of have a chunk of stuff, and then I have some code examples after that. So I know it's like wall of text right now, but I'm kind of going to go over everything and then go over things that I'm going over here individually so you can kind of see what I'm talking about. So the idea with the first version of Frisby was to create my own kind of testing syntax that kind of abstracted away the test framework itself. So when you created a Frisby test, you would call Frisby create, and that would generate the. Is anyone familiar with like Jasmine or Jest style syntax? Okay, you have these blocks where you have describe, and then you have it, and then your test is inside that block. So the first version of Frisby would actually create this block for you when you run the test. It didn't end up working out too well. That ended up being a huge blocker for me later down the road that I'll explain why once you see some code. So the code, I think, in some ways looked a little bit cleaner that way because you didn't have all the test syntax in the way, but it was also very inflexible that way. because since it was generating the test for you, you couldn't do custom things. It used JavaScript built-ins for type comparison, and you'll see some of that in code. I'll just go over this kind of quick because code's more fun to look at. The test runner is probably one of the most important things of this, though, and one of the biggest reasons I did a rewrite, and the timing that I did the rewrite had a lot to do with when Jest came out, or when Jest was really, it wasn't right when it came out, but it was really when it started kind of getting super popular in the JavaScript ecosystem. So Jasmine Node was the test runner, and the big problem with this, if you think about HTTP tests and what they have to do, you really want something that runs all of the tests in parallel, which means, just fires off 10 of them at the same time, and it doesn't wait on, the previous one. So Jasmine does run all the tests in random order. Jasmine generates a random seed and then randomizes your tests, just to make sure that, this test up here is not dependent on this one, the one above it or something like that. So it does randomize the order, but it runs the tests synchronously, which is a big problem for HTTP tests. These test suites are actually taking quite a long time to run. If you think about, if you're testing your full API, you're probably making hundreds of HTTP requests, and you have to wait one after the other for that. So I saw that. It was a problem really from day one. The tests were always going to be slow, but it was such a business need that it didn't really matter. It just had to be not breaking the API, not breaking all of these clients that consume the API was more important than the test necessarily running fast. The landscape of the test runners, asynchronous test runners, was really not that great in 2011, so I kind of just used what was there. I very strongly considered writing my own. We didn't have budget for it on that project, and so we had to kind of use this as we went. I'll go on. You can probably read the other point there. So in 2017, the JavaScript landscape had really shifted. ES6, ES 2015 had, was getting very popular. It's reaching a lot of adoption. The versions of Node had built in a lot of the features, so you didn't need to transpile anything if you're running it with Node anymore. Promises were everything promises, and then later async await had come out and were fully integrated, with Node. So you didn't have to use a library like Bluebird. Has anyone used Bluebird or familiar with promises? Okay, it's just a library that emulates promises when they weren't supported. But and Jest was really key for this rewrite, and it's the reason that I decided to go ahead and do the rewrite, because I didn't want to do a rewrite with a slow test runner again, because it wasn't going to be that much of a benefit. So the third bullet point here, Jest is the test runner. It's a really, really great tool for parallel test runs. It basically sandboxes your code so that it runs completely separately. It reduces side effects, basically, so that this test, anything it modifies, you can still modify global variables and stuff like that, but it sandboxes the process so that if there's anything in the actual process that might affect the other tests, it won't anymore with Jest. And then it runs them fully parallel, so it's fully asynchronous. So now Frisby tests can run much, much, much faster, depending on your settings on how many parallel processes you allow Jest. It's also very well supported in the JavaScript ecosystem. So this is about the time where the Facebook team had released React, and they released Jest, testing for React, and they have all the tooling already released for continuous integration builds to report things like code coverage and pass fails and stuff to CI builds. It's all built in Jest. So big help for me. I was able to just use that. While I was in rewriting it, I also did a number of things differently, hindsight being 2020. I reduced the API service to simplified some things, and I'll show you some of that in code. So the basic tests in version 1 look like this. So you would call Frisby create, and then the name of the test. You would get some URL and then run some assertion. And there's several different assertions you can run. They're expects. So I borrowed the terminology from Jasmine and Jess, where you expect something to be or to equal, something else. So if you're going to hit an endpoint and you want to test an HTTP status, this is the test you would run. So in Frisby version 1, you would have to say Frisby create, and then you would have to do a toss at the end, which, like toss a Frisbee. That's why I named it that instead of send. I don't know. It's playful. It's open source and it's free, so you can't complain. In version 2, so this is what this test is doing. So when I said create is generating the it for you, this is what it's doing, basically. So in version 2, Frisby focuses, I kind of narrowed the focus on Frisby to only do the HTTP calls and assertions. So it's not generating any tests for you now. So now you have to nest it yourself. Sounds like more work. This may look a little bit cleaner than this, but this is way, way, way better in a lot of different ways. So one of the things you might notice is I'm returning here. I'm saying return Frisby.get. What this does for Jest is when you return a promise, basically this is returning a promise. This is actually returning a Frisby spec object, which inherits from promise. So the browser thinks it's a promise, and it has like then and catch and stuff on it too. So it kind of acts like a promise. So when you return a promise inside a test assertion block in Jest, it will wait on the result of that promise. And then it will attach its own like then and catch handlers, which basically are the then handler gets executed if the test was successful. The catch handler gets executed if an exception was thrown in the test. So what Frisby version 2 does in the assertions is if it doesn't match the assertion, I'm throwing an exception. And that's getting caught in the promise, and it's resulting in a promise rejection, which is then getting picked up by Jest if you return the promise chain. So this is the syntax. Probably a little bit more that you have to write, but the result of this is that you can effectively build your own promise chains now with Frisby as a native promise object. Just kind of pretend Frisby spec is a native promise object. You can build your own whole promise chain. So I'll show some more code for that a little bit later. There's some stuff in there that I want to show you. Kind of going to go through several examples. If you have any questions along the way, you can just raise your hand. I'll just take the questions as we go. So for version 1, I had a different method for every assertion. So we expect status, we expect JSON types, and that asterisk in front, this is a path. So this is kind of special in Frisby. In a JSON response, you might have an array of items. You might have an object with a bunch of keys. You might have stuff nested. There's all kinds of things that you might have. So the first parameter in expect JSON types is a path, and the asterisk, what that is that's saying every item in the array. Test for this. So this get call is expecting an array response, and then it says for every item in the array, make sure all of these properties are present with these types. So make sure user ID is a number, and ID is a number, and title is a string, and body is a string. So that's what that test is doing. This is the version 2 equivalent. So I hit my trackpad there. So this is version 2 equivalent. We're doing the same thing. We're returning it inside the it block. Frisby version 2, instead of using JavaScript built-in prototypes, though, to run the test, it uses Joy. Has anyone used Joy at all, or know what that is? Okay, so Joy is a validator, a data validator for Node, for Node.js. It's intended to be used server-side. There are some client-side ports, but it's pretty big as a package size if you try to include it client-side, so I wouldn't recommend it. But Joy is, but these tests are all run with Node, so it's all server-side. Joy was created by Walmart Labs, actually. They released a tool called Happy, H-A-P-I, and then released a tool called Joy. If you're familiar with the cartoon that references. So where am I going with that? Yes. So if you look down on the JSON types, I'm now just calling the expect function with an expect handler name. So expect status, 200, expect JSON types, asterisk, and then the same property assertions with a joy style validation. The reason why I moved to joy was because the built-in types here were pretty limiting. And honestly, JavaScript needs a little bit of help sometimes when it's doing type determinations. For instance, if you had a nan, if you say type of nan, it's actually number. So type of not a number is number. So a nan would actually pass on a number type, and kind of silly things like that JavaScript does. It doesn't do. The type of operator in JavaScript is super wonky, so I ended up having to code in some. I ended up on this having to grab the native types that were used, the prototypes, and then do some funky stuff to compare and make some. I wound up building in some logic to make some guesses on what the user wanted to do that wound up being a problem later down the road when they didn't want to do that, and you can really change that because it's just a single declaration. You're saying to JavaScript, use the number prototype here, use the string prototype here, and then I would check against that. So Joy allowed a lot more fine-grained control. It also allows things like casting and lowercasing and whatever else you want to do. It allows you to say if a property is required or not. There's a ton of other stuff in Joy. It's a really good validation library if you're doing something with Node. I would highly recommend it. Also on Joy, if you throw if an error is thrown with Joy, it gives you like the full path to the key, and it helped me return a helpful error back to the user. Like this test failed because user, data.userid, well, in this case it's an array, so it would be like 0.userid does not, is not a number or something like that. So it would give me a helpful error message with a path that I could show to the user, and then they could look at that JSON that they got back by running inspect.json. If you put an inspect.json on here, the console logs out the JSON and it just dumps it and lets you look at it. So let me do some cool stuff. So with nested tests, an example would be like here, I'm fetching all the posts, and then I'm getting the comments for the first post. A better example might be if you have to, if you create an item, and then you want to see in the list of things if that item you just created is there, or if you need to log in first to do something, and then you need to do something else with the login. So this is version 1. I had this block called after JSON, which really is just kind of like a then. So it's kind of like a promise, but it's not, and it's a different syntax you have to learn. And I had an after block, which was more of a raw block that gave you like the request and the response and the body. And then after JSON block, which actually parsed the JSON and then fed it to you as JSON so you could look at it. So I'm just doing a Frisby create inside of Frisby create. Earlier in the presentation when I said that generating the test kind of became a problem, this is really, doing tests like this actually wound up to be super flaky, because Jasmine, essentially what's happening here is the first test is running, so it's creating the it statement, and Jasmine sees that right away because that function's executed right away. But in the after JSON block, it's not executing that until after that response has come back. So now I'm creating another assertion, a test block for Jasmine dynamically, asynchronously after this other test runs. And the problem is Jasmine didn't really pick that up. So it would run the first time and say, oh, I have 5 tests. And it's like, no, actually you have 32 tests. They're just a bunch of nested ones. And so it would just do weird things. Like sometimes it would know about them, other times it would, most of the time it wouldn't, and it would fail, and it would just be in super flaky. It took me a while to figure out like what the heck was going on. But once I realized this, this is kind of when I knew, I'm like, I have to ditch version 1. Like nested tests are not reliable. There's no way to resolve this. And it has to be a breaking change because since the tests are generated here, there's literally nothing I can do syntax-wise or inside Frisby to create this. So I did all kinds of things, like I dug into the internals of Jasmine and tried to like add tests dynamically and things like that, and it just it wasn't having it. There was nothing I could figure out how to do. So ended up being something. I guess the biggest thing that would happen was you would, the test reporter would say that all the tests passed if your initial test passed, but then you'd still get the failures reported out in the console and stuff if your nested test failed. So you would like know the test failed, but it wouldn't necessarily be in the reporter. It was all kinds of weirdness. So with version 2 being promise-based, essentially what you're doing now is you're building a promise chain. And since Jest supports returning promises inside tests, I am simply returning Frisby.get and doing my assertions, and then I'm doing a .then, just like I would on a promise chain. And then I'm returning, down here a little further, I'm returning another Frisby fetch with another assertion attached to that. So with the promise chain, now Jest knows to wait until that promise chain is fully resolved before it's going to pass or fail that test. And since all the tests are run asynchronously, they can be nested as deep as you want to nest them, and it really doesn't matter. Also, since I'm returning this, the side benefit is that now I can compose my tests better. So I can start to split these things out into individual functions. I can compose them. I can return from the function call that will return my Frisby tests, and do a lot more things with them that really help me scale my tests in a large code base, especially against a large API. The uversion API had hundreds of API tests, and it was getting very slow to run. And it was a lot of nesting stuff. So in a code base like that, version 2 will help a lot with breaking those up and nesting them. Okay, so if you want to run some custom expect assertions, I support that. All you have to do is .then, since you're inside an it block, since it's just Jasmine syntax. So if you're using Jest, you're used to this expect something to be, or to equal, or to be greater than, or less than, or whatever. There's a ton of matchers you can use. But all of the Jasmine matchers that Jest supports are also supported here. And Jest actually also adds their own matchers, like to-match snapshot and things like that, if you're familiar with Jest. So if you want to use those expects to test for a certain thing, but then you want to take that and make that more reusable, there's extensions are built into Frisby 2. And what you do is you call this function called addExpectHandler. So I'm using I can't click on the slide without changing it. I'm using a before all function, which is defining this isUser1 function, basically, that accepts the response just like a normal Frisby test. And then I can run all my custom assertions or do whatever I want to do that will pass or fail that test, so they'll throw. And then down here on the bottom, I can do expect and then the name of the expect handler that I added. So this basically lets Frisby use the same test syntax for all the built. This is really what the built-in expectations do. So it adds a bunch of default expectations, and then you can add your own also. So this lets you do, really anything you want to do and test for anything you want to test for in a way that's super easy to use. If you have one config file that imports Frisby and does all your setup, then you can just include that and then use all your tests and just use the custom expect handler anywhere. So it allows a level of flexibility that was not in version 1. In version 1, I had an issue record on GitHub that someone filed that they wanted me to export the prototype, the Frisby object prototype, so that they could add methods to it to put their own assertions on it. And we went back and forth a little bit, and I ended up doing it because in JavaScript you can add methods to to an object prototype anytime you want at runtime. The object's never closed, per se. So you can mutate that. And I allowed it because there was no other built-in way in version 1 to do it. And doing it at that point, while I knew the problems with it, I decided to do it this way in version 2 so that it's exactly built in, used exactly the same way as the default expect handlers, so just right in line. If you want to run that expectation, so if you add your expect handler and you want to run it without actually sending an HTTP request, there's a from JSON block. So Frisby uses this a lot internally in its own test suite. So I use this to test Frisby's own assertions a lot. So I'll say from JSON, and this creates a response object that resolves a promise that you can then run assertions on as if you had fired an actual HTTP request. So this is useful if you're writing your own expectation handlers or you're running your own custom assertion logic that you want to make sure works without actually having to slow down your tests by making it an integration test. You say I just threw an example of JSON types and JSON in here that would run the assertions against that. Mutating the request. So there's also helpers in Frisby to change the requests as it comes in to add things to it. A good example of that would be a request header for like authentication or sending a token or something like that you might have to send with each request. There's a use function that you have to use before you send the HTTP request. So as soon as you call, get, post, put, delete, patch, or fetch, if you want to customize how things are sent, you can also call it Frisby.fetch, which is what get and post, put, and delete wrap the fetch API, if you're familiar with that. It's a native API built into browsers that uses promises. It's the basis of Frisby. So if you call .use, you can call this, it basically will pass this current expectation that you're building in here. So it's passing the Frisby spec object in here, and then you can actually call methods on it. One of those methods is setup, and setup lets you add things to the request or the response or well, I think mainly requests right now, but it's going to let you add a header. So right now I'm saying Frisby at the bottom. I'm saying Frisby.use with basic auth, and this is a function that is going to call. It's going to add an authorization header for basic HTTP basic auth for this endpoint, so that when I call this get function, any setup that's been done is going to be merged with any setup that I do per test. So .setup, you can use like Frisby.setup right here in line to set, add any headers or whatever you want, and you can also do it in another function. So this is just, yes, go ahead. Do I have to do the use every test? If you want to do it this way, yes, but there is another way that I'm going to show you. The use function is primarily for things that you specifically don't want global. So if you're testing how an API, or what an API returns with an unauthenticated request versus what it returns with an authenticated request, you're going to want to use the use function to return different tokens and test with different tokens. Another example is if you have different levels of users or different roles or something, you're going to want to say like, with super admin or with member only or without login or something. You'll have multiple roles that you'll test. It's just a convenient way to break those up. And then those functions obviously can go in another file, and you can import them and reuse them wherever you want. So another thing you might want to do is set up or log in before tests. This is another example using before all. So what I'm doing here, and this is, I think, what your question, Brian, was alluding at, is that is there a global setup, right? So there actually is a global setup. but it truly is global, so you have to be careful with it. So it's, well, yeah, it's, yeah, I say it truly is global in that when you use that, it's for the whole jest run, basically. Whenever it hits a global setup, it will affect every other test in that whole jest run. So it's really useful if you have different test suites for like authenticated or non-authenticated or whatever. You can just use global setup. So what this is doing is this is dynamically logging in to my API. I threw an expect not in here just to show that that's in there. You can do expect or expect not. Expect not just negates the assertion. So it wants to see an exception thrown, and then it passes if one's thrown. That's really all it does. And then if I'm at the then function, nothing's been thrown, so it's been successful. So now I'm gonna do a global setup with a header, an authorization header. And then when I get the users down here, it should succeed. It should return a 200, not a 403, because I've done a global setup in the before all. So it's just another way to kind of set up your test or set up your test suite in a way that if you need a login or a cookie header set or something like that, you can do that. If you want to know more about Frisby or where the code repository is, my GitHub username is vlucas. It's at github.com/vlucas/Frisby. If you look for it on NPM, it links to this also. Frisbyjs.com is full docs, so it's got all the APIs you can use. It's got examples. It's got example responses. It's got some samples of how to do a file, like a file uploads testing. I've had this question asked a lot, and some more advanced things as well in there. So if there's any questions, I can take those. Otherwise, just wanted to point out that, again, Thunder Plains is on October 22nd. So if you haven't got a ticket, please get your ticket. If you want to use the discount code, I think member20 off. Devin, can you pull that? I think it's member20 off as a discount code if you want to get a 20% discount. And I just want to give a shout out to my current employer, which is RentPath. So if you're looking for a new place to rent or whatever, rent.com or apartmentguide.com, check them out. Any questions? All right. Well, that's the presentation. Thanks, everyone.